worked on in the past. And when doing this project the first time, I experimented with various render settings and material settings to get the look that I wanted. But like most veteran users, I tend to use the same general approach to each particular type of scene. For example, I usually render exterior scenes with an irradiance map and a light cache, and usually start with my typical test and production settings. But every scene is at least a little bit different and a little bit unique, and all are going to require at least some experimentation. Also, situations do occur from time to time that warrant using other methods than the one you rely on most often. In this module, I'm going to show numerous different lighting and rendering approaches and provide a review of as many different VRAY features as I can. I'll describe the process that I would go through to light and render this scene, and then I'll describe some of the other ways that you might approach your scenes based on what the final product is, the time that you have available, and problems that you might encounter along the way. And I constantly tell students over and over again that knowing VRAY well means knowing how to troubleshoot your scene. And by this, I mean knowing some good settings will rarely lead to efficient quality renders because, as I just stated, every project is different, and settings that might result in a great look to one scene might result in a horrible look and excessive render times on another scene. What can really make your work agonizing is struggling with the myriad of problems that can arise with any project. Problems like splotches, noise, flickering GI, strange dots, running out of memory, excessive render times, system crashes, lack of detail, and so on. So the goal of this module is to demonstrate a good approach to a typical scene, and then I'll intentionally create some problems with this scene and demonstrate some of the ways to fix them so that you can apply the same approach when you run into the same problems with your scenes. So let's go ahead and start, and if you want to follow along, open the file called hampton01.max. This is a project that 3DAS worked on for the hotel chain Hampton Inn, and just so you can see what I'm going to try to reproduce, here are the final rendered images. Now, rendering a scene of this size will take too long to show in real time, so most of the time when I render, I'm going to immediately skip to the final image rather than making you wait each time. It just wouldn't be practical to do it any other way. Also, in this project, I used a program called Onyx for all the trees and plants, and unfortunately I can't distribute these models, so the scene that I've made available contains no landscaping. Landscaping will obviously change the look and feel of a rendering, but when you're working on a scene in a production environment, I would either hide all the vegetation anyway to minimize render times, or I would just wait to populate the scene after the lighting has been set up. So I wouldn't be rendering with these objects in the scene anyway, at least for test renders. Therefore, I'm not including the vegetation in this tutorial, and that should be just perfectly fine. Likewise, I can't distribute the cars shown in one of these views because they were purchased through Sure 3D, but those two would not be shown during the lighting setup anyway. I want to give a little background information about this scene before I begin. It's a fairly small scene which contains about 930,000 faces, not including the almost 10 million faces contained within all the VRAY proxies that you see around the scene. The VRAY proxies in this scene were basically the 3D cars that you see, the 3D trees in the foreground, and in the background I have a standard 3D background rig that I use for almost every scene. It contains two cylindrical objects which are visible with the camera but not visible in reflections, and it also contains a hemispherical object which is visible to reflections but not actually visible through the camera. Notice also that I'm using 2D trees in the distance to break up the horizon line. You never want to see the horizon unless it's on the water, so to break up the background, I scattered various 2D trees around the perimeter of the scene, as well as some individual faces, which at a distance looks like underbrush. And this is a really good way to create backgrounds for your visualizations. It's simple, it's streamlined, it doesn't take very long to render. And if you want to read more about this, you can check out the Visualization Insider article entitled A Little Background Information, and that's on CG Architect. One more important note I need to make about the background rig is that all the objects that make up the background are illuminated independently of the rest of the scene. The three sky objects are illuminated by a single omni-light positioned directly in the center of the background objects, and the 2D trees are illuminated by 4 direct lights positioned around the boundary of the scene. And this was done so that the brightness of the background objects could be controlled easier and separately from the rest of the scene. And I'll be talking more about these background objects a little later, but what's important to note right now is that any light that I add to this scene will automatically want to illuminate these objects. So what I need to do each time I add a light to the scene is to exclude these objects from the effect of the added light. And I'll demonstrate this when lights are added. Finally, if I click the background dome or cylinder objects and select VRAY properties, notice that I've disabled the generate and receive GI options. This is important because these objects are very large relative to the other scene objects, and if these options were enabled, they would cast a tremendous amount of GI on my scene, so much so that they could completely change the appearance of whatever skylight that I use. Okay, well, before I add my first light to the scene, I want to highlight something really important about any scene that you work on. The brightness of a scene is obviously dependent on the intensity of the light sources, but it's equally dependent on materials in a scene. As you probably know, in the real world, dark colors absorb light and bright colors reflect light. Well, in VRAY it works the same. I often see users trying to add lights to their scenes before applying